Hello and good day to all. My name is Rainier Samos and I'm here together with my partner Francis Principio to talk about the primary and secondary controls of an aircraft. Before anything, let's first have a short recap and discuss how exactly an aircraft flies. As we all know, there are four main forces that affect an aircraft in flight. First is the thrust, which makes the aircraft move forward and is powered by the power plant or the engines. Next, we have drag. It is the force that opposes the thrust and is created through the collision of the aircraft's body against the air. Third, we have weight, or how gravity pulls downward on an aircraft's mass. Lastly, we have lift, which as the name suggests, is the force that lifts or makes the aircraft rise. Lift is generated by the wings and their unique shape called the airfoil. It passes through the air in such a way that the airflow above it moves faster than below the airfoil. This gives the air below a higher pressure than that of the air above, which basically causes the lift. With these in mind, let us now proceed with the aircraft controls, starting with the primary controls, which are the systems that input the general movement of the aircraft along the three principal axes, namely the longitudinal, the lateral, and vertical. Movement around the longitudinal axis is also called roll. This is controlled by the ailerons, which are located on the aircraft's wings. The nose up or down movement about the lateral axis is also called pitch, which is controlled by the elevator usually mounted on the horizontal stabilizer of the empennage. And lastly, the direction where the nose points or movement about the vertical axis is also called yaw, which is controlled by the rudder on the vertical stabilizer of the empennage as well. Additionally, the rudder also controls nose wheel steering if the aircraft is taxiing or on the ground. Aside from these main systems of controls, there are also mixed options which combines two systems into one. First, we have elevons that combine the functions of elevators and ailerons, commonly used on delta-wing aircraft. Ruddervator means rudder and elevator commonly used by twin-tail aircraft. And stabilator, which combines horizontal stabilizer and elevator into one piece. There are also combinations of primary controls and secondary controls like flaperons or flaps and ailerons. Now let's take a look how these systems are put into action. Here we have the cockpits of the two biggest aircraft manufacturers, namely Boeing and Airbus, which seem a little different. Here we have the rudder pedals, while these are the yokes. Airbus employs a joystick-type yoke, while Boeing adopts the traditional yoke style. However, both have the same intent of operation. Let's use this joystick and pedals as a representation of the yoke and rudder pedals. The forward and backward movement of the yoke controls the elevators, such that when the yoke is moved backward, the elevators deflect upward to lower the tail and raise the nose. Conversely, when the yoke is moved forward, the elevators deflect downward, which raises the tail and lowers the nose. The sideways movement of the yoke controls the ailerons, such that when the yoke is turned to the right, the left aileron will deflect upwards to raise the left wing, while the right aileron deflects downward to lower the right wing. Likewise, if the yoke is turned to the left, the right aileron will deflect upward to raise the right wing, while the left aileron will deflect downward to lower the left wing. The yawing of the aircraft is controlled by the rudder pedals, such that if the left rudder pedal is pushed, the rudder will deflect to the left for the nose to go left. Conversely, if the right rudder pedal is pushed, the rudder will deflect to the right for the nose to go right. In this clip, the aircraft is executing a maneuver called crabbing, which is performed during crosswind landings. The aircraft must face the direction of the wind, meaning that it must approach the landing strip diagonally and turn to its direction at the last minute in order to not be blown away. From this, we can say that the pilots must have the highest degree of mastery of the aircraft controls in order to operate it properly and safely. That's basically it for primary controls. Let me pass you to my partner Francis to discuss the secondary controls of an aircraft.
So good day to everyone, I am Anthony Francis Principio. Now let's proceed with the secondary controls. These are used to assist the operation of the primary flight controls, provide ease to the pilots, and control other aircraft movements. So the first one is the flap. This increases lift and drag to be able to maneuver the aircraft at lower speeds. Here are some examples of flaps. The first one is the plain flap. Next is the split flap. Then the slotted Fowler flap, the slatted flap, and lastly, the Fowler flap. Next is the control tab. This is used to assist the pilot's feel of the controls in order to make it easier for them to maneuver the aircraft. The first type of control tab is the balance tab, which moves in the opposite direction of the input in order to lighten the control. This means that when the elevator moves up, the balance tab moves down. Then next we have the anti-servo tab, which moves in the same direction as the input to increase the feel. So when the stabilator moves up, the anti-servo tab moves up as well. Next, let's proceed to the trim tabs, which reduces the work needed to stabilize the aircraft by counteracting the aerodynamic force produced by the primary controlled surfaces. It lets the pilot lighten the grip on the yoke since it helps in adjusting the said inputs. The next is the spoiler, which decreases the lift generated by the wing. This allows the aircraft to slow down as it prepares for landing. The two types of spoilers are the ground and flight spoilers. Ground spoilers generates reverse lift that pushes the aircraft down to the landing gear to help in slowing down the aircraft. Flight spoilers, on the other hand, reduce the lift generated by the wing in flight to help raising the other wing in rolling movement caused by the ailerons. And lastly, on the leading edge, we have the slats. This increases the camber of the wings from the leading edge and allows air to pass from below to the upper surface in order to increase lift, similar to flaps. And that is all. Thank you for listening.